Welcome back, my dear friends. Uniformly accelerated motion, we are going to start from here. Uniformly accelerated motion. In the uniformly accelerated motion, we have 5 equations. We are going to try to derive most of them. The first equation of motion, we know that acceleration is equal to the change in velocity over the time of the change. And we know that the change in the velocity is final velocity minus initial velocity divided by time. If we are going to make a cross multiplication, so v minus u is equal to at. I'm going to move the negative u to the other side. I'm going to change the sign of it, so v is equal to u plus at. And here is the first equation of motion. Let's move to the derivation of the second equation of motion. In the second equation of motion, where s is equal to ut plus half at squared, we are going to derive this equation, guys. Let's start by the average velocity. What is the average velocity? If we have initial velocity and we have final velocity, in order to calculate the average velocity, we are going to find the average like this. The initial velocity plus the final velocity divided by 2. Here is the average velocities, and actually it is a constant velocity. So average velocity as I mentioned, it's a constant velocity. Okay, guys, and let's move. We said that, or we just derived that v is equal to u plus at. We are going to substitute here in v. So v dash is equal to u plus at divided by 2. If we are going to add the initial velocities, so we will have 2u plus at divided by 2. We cannot cancel the 2 here except after taking 2 at the common in the above of the fraction. So 2 is equal to u plus half, since I took 2, and we have 1 is equal to 2 over 2, so half at divided by 2. At this moment we can remove the 2 or cancel out 2. We still have the average velocity. We need to derive this. If we have a constant velocity, constant velocity is equal to displacement over time. S here for displacement. So if we are going to make small change, S is equal to Vt, rearranging this equation. So I need S on the left hand side. So we need to multiply the left hand side by t. And if we are going to multiply the left hand side by t, we have to multiply the right hand side by t. So we are going to multiply both sides by t. What we will have, v dash t equals, I'm going to multiply t by the the brackets, so we will have ut plus half at by t will give us t squared. V dash t is equal to, since v dash is the average velocity and we said it's a constant velocity, so constant velocity by time will give us displacement, so displacement is equal to ut plus half at squared. Okay, guys, so here is the second equation of motion. A small modification in this equation, we will have the third equation. S is equal to ut minus, S is equal to Vt minus half at squared. So we are going to change u by v, and we are going to put negative sign. It will give us, it depends on the given data in the problem. We are going to use it in solving problems for objects moving with constant acceleration or uniform acceleration. So till now we have 3 equations. How we are going to represent or derive the second equation graphically? Let's assume we have a velocity time graph. So we are going to return to the graph. We are going to draw the graph. We have a velocity time graph, and we have the state of motion, or the state of the object. The object is moving with a constant acceleration. Here is the velocity and here is the time. So at this point we are going to consider it u, the initial velocity, and at that point we have v. I'm going to put some dots here, and I'm going to drop a line here for the time covered from the object start moving till the end of the motion. We know that in velocity time graph, distance covered is equal to area under the graph. So in velocity time graph, distance covered or displacement covered equals area under the graph. Okay يا شباب, so distance covered equals to area under the graph. So we need to find the area under the graph, this area. I'm going to divide it in two sections. It's like we have a triangle and a rectangle. Here is the rectangle and here is the triangle. We are going to find the displacement. Displacement is equal to area of the rectangle plus area of the triangle. So we are going to add them together. What is the area of the triangle? Is u, rectangle is ut, length by width. What is the area of the triangle? Is half base by height. Base is t and the height is here. Here is the height, the distance between these 2 points. So it's v minus u, v minus u. We know that from the derivation of the first equation, a t is equal to v minus u. So we are going to remove v minus u and we are going to substitute by at. So s is equal to ut plus half at squared, and here is the derivation of the second equation graphically, or the graphical representation for the second equation. We are going to move to the fourth equation. We know that s, the first equation, we are going to met the first equation, the second and the third at these derivations. We need to prove that v squared minus u squared is equal to 2as. We know that the first equation, v is equal to u plus at. What I'm going to do, I'm going to square both sides. The left hand side is easy to be squared, so it will be v squared. The right hand side, I'm going to square it like this, like perfect square. If we have first plus second, I'm going to make it squared. So first squared plus 2 by first by second plus the second square. I'm going to do the same here. I'm going to square this, so it will be the first square u squared plus 2 by first by second 2u at plus the second squared a squared t squared. And then we are going to move the u squared to the other side, v squared minus u squared. I'm going to move it to the other side. I'm going to change the sign. So v squared minus u squared is equal to 2u at plus a squared t squared. I'm going to take 2a as the common factor. What is left for us? 2a and a, we are going to remove it, so ut here plus 2, so we will have half. I'm going to take one of a's, so we have a and we have t squared. So ut plus half at squared represent what? Correct, represent displacement. So v minus u squared is equal to 2as, and here is the fourth equation. The fifth equation is an easy equation. If we have the first, the initial velocity and the final plus the initial divided by 2, we are going to find the average, multiplying by time. It will give us the displacement covered, and here is the 5 equations. I'm going to write the 5 equations here. Here is the first equation, v equals u plus at. The second equation is s equal ut plus half at squared, or s equal vt minus half at squared, and we have s equal v plus u divided by 2 all multiplied by t, and we have the fourth, which is v squared minus u squared equal to as. So we have 5 equations. We are going to use them in solving problems related to the object moving with constant acceleration or uniformly accelerated motion. We are going to stop here, and we are going to take a lecture for practicing how to solve problems related to uniformly accelerated motion. Okay guys, until I meet you, I wish you all the best. We are going to stop here.